Welcome! This is a second section of our Hadoop'able course, and in this section we will be looking at all technologies that we will be using throughout this course. So this section will be more theoretical about each of these technologies to understand why we even need to use it. So this is a second section, downstream ecosystem. We'll be looking at the Hive technology, Apache Kafka, HDFS database, Apache Spark, that is MapReduce paradigm applications, and Spark streaming. And this is the first video in which we'll be looking at the Apache Hive for ETL and SQL-like processing. We will see how to use Hive with HDFS and what is a Metastore component. So what a Hive is? This is a data warehousing infrastructure based on Apache Hadoop. Hadoop provides massive scale-out and fault tolerance capabilities for data storage and processing on commodity hardware. We already know it because we learned about it in previous section. And Hive is designed to enable easy data summarization, ad hoc querying, and analysis of large volumes of data. It provides SQL, which enables user to do ad hoc querying, summarization, and data analysis easily. At the same time, Hive SQL gives users multiple places to integrate their own functionality to do custom analysis, such as user-defined functions. And let's introduce the first concept from Hive. So first concept is database. So this is a namespace function to avoid naming conflicts for tables, views, partitions, columns, and so on. Databases can also be used to enforce security for a user or group of users. Also, we have some kind of tables, because this is some kind of database. So tables is a homogeneous units of data which have the same schema. An example of a table could be page views table, where each row could comprise of the following columns schema. So this is an example Hive schema. We can have a timestamp, which is of int type. We can have user ID and could be a big int. We have a page URL, which is of string type. We have referral URL, which is of string type also, and IP, which is of string type. And this is an example schema of page view. So we have user ID of page view URL, and other informations that could be used for the page view object. And let's see a data abstractions in Hive. So at the top of it we have a database. So this is naming namespace. Inside of database we can have multiple tables. And first table can have multiple partitions. So for example, partitions first is for the first day of the specific month, second is for second day in a month, and so on and so on. And inside of the partition we can also have buckets of data. And each table in Hive can have one or more partition keys, which determines how the data is stored. Partitions, apart from being storage units, also allow the user to efficiently identify the rows that satisfy a specified criteria. For example, a date partition of type string and country partition of type string. And each unique value of the partition keys defines a partition of the table. For example, all US data from 2009, 12, 23rd is a partition of the page views table. Therefore, if you run analysis on only the US data for that specific day, you can run that query only on a relevant partition of the table, not on the whole dataset, and your computation will be faster. And however, that just because a partition is named 2009, 12, 23rd, it does not mean that it contains all or only data from that date. Partitions are named after dates for convenience, and this is the user programmer job to guarantee the relationships between partition name and data is correct. So this is only a virtual name. And here we have, for example, choosing a partition scheme. So we have Twitter tweets table and partition is ID and date. Then we have stats by Twitter daily table, and it is partitioned only by the date. So if you want to find out statistics for a specific day, we can only look up data for a specific day and analyze that day. And this is Hive architecture in grasp. So we have HDFS or Edge-based data storage underneath. So all data resides on HDFS. At top of it, we have Hive. So we have a Metastore that stores meta informations about all our data. So it has information where partition is located on the HDFS file system and so on. Also we have query engine, that is Hive query language process engine and execution engine, and we can swap that engine. For example, here we have MapReduce, but we can also use Apache Spark as the execution engine. And we have multiple user interfaces. So we have web UI, Hive command line, and so on. We can create new interfaces if we want to. And this is architecture in details. So on the UI we are executing query, then driver is compiling our plan. It gets the data from Metastore and sends plan to driver. Then it goes to the execution engine that starts job. Job is starting using multiple nodes if our cluster has multiple nodes, and it executes map and reduce tasks. After job is done, it signals that fact to the execution engine and it sends results to driver. And UI is fetching results from the driver when the result is available. And in Hive we have one special component called Hive Metastore, and it refers to the H catalog, is a relational database repository containing metadata about objects you create in Hive. So when you create a new Hive table, the table definition, column names, data types, comments, everything is stored in the Hive Metastore. This is automatic and simply part of the Hive architecture. And that Hive execution engine, MapReduce engine, could be switched out to Apache Spark, Test, Hadoop MapReduce, or other engines.